Hi, in this lesson we're going to start off looking at scale factor and similar shapes. So it's a particular topic in maths. We can look at different types of shapes, 3D shapes, 2D shapes, and we can look at this idea of scale factor and similarity. So let's have a look at some of the words that we're going to have to think about in this topic. The first is the idea of being congruent, and congruent is a particular word in mathematics. It means exactly the same. So if we were to think about kind of shapes that are congruent here, we're looking at shapes that are exactly the same. So if I were to move these, this is usually something I get one of my students to do. Can we judge whether these shapes all look the same? These ones are not congruent, they're all different. Let's do that. Is this one here, is that congruent? I think this is certainly not the same size. This one looks different. Here, the purple one. In actual fact, it's quite interesting when you turn it around, you can actually see that it's exactly the same as these other ones. So I wouldn't say I would say it's congruent, but it does actually look, because it's set up a different way, even the dimensions look slightly different. So congruent shapes are ones that are exactly the same in terms of their dimensions, and shapes that are different are obviously not congruent. So what's the difference between that and similar? Well, similarity is about the idea of them being in proportion. In other words, it looks the same whether it might be a smaller version or it might be a bigger version, larger version, but it looks as though it's maybe the same shape far away or close up. In other words, there's a proportion to it. Looks like the same shape. Maybe one's a bigger version, a blown up version, or a reduced version. So we're looking at this one here at the top with the yellow border. What shapes are similar to that? Well, you might get a feel for it. It looks as though some of them are quite easy to tell. That looks taller than it should be, so that's not similar. This one here is definitely not in the same proportion. It definitely looks different. We'll put that there. This one here, it's a bit tricky to tell. I think this one at the bottom is not in proportion. It's not the same kind of dimensions there. I think these ones are probably about the same. Do you see what I mean by the fact that they're all different sizes, but they all kind of look in the same proportion? So what I'm going to do is, just to check, I'm going to bring this one up here, and I'm going to just drag the corner. That's one way we can check. And you see how it just sits right in there. So in actual fact, it is the same shape. It's just been reduced. Let's check this one here. That's exactly the same. So that's actually congruent. And this one here, if I set this one in place, well, let's enlarge the other one. Okay, does it come out to the same corner? Yep, it does. Okay, so this is a tool that we've got in a lot of programs, desktop publishing, or even Microsoft Word and things. If you select a shape and you drag it down in the bottom right hand corner, it enlarges and reduces it, and every time you stop it, you've made a similar shape. Okay, all these shapes are similar. So there we go. That's the idea of a similar. Shapes are similar if they have that same kind of proportion. Now, mathematically we can define it a little bit better. Okay, so what we say is that shapes are similar if it's an exact enlargement or reduction, and all the sides have to have the same scale factor. So this is the key thing that helps us to work out if shapes are similar or not. In other words, all the sides should have the same scale factor, and that's a multiplier. Okay, so in other words, we can say here that if the scale factor is bigger than 1, if you multiply any dimension by a number bigger than 1, it's going to make that dimension greater. So say 2. So if you take a shape and you double all the sides, of course it will look like a bigger shape. If the scale factor is less than 1, it's going to make the new shape smaller. It will be a reduction. In other words, if you halved the size of all the dimensions in a shape, it's going to look like a smaller one. Okay, so the scale factor is a multiplier that you apply to each side of a shape, which tells you what the new shape is going to look like. Okay, so let's have a look. Today we're just going to have a look at drawing shapes. So we'll need some squared paper, hopefully. So I'm going to put these three shapes up on the screen here. And it says for each shape, draw the original and then enlargements with scale factors of 2, 3, and 1.5. Okay, so the way you do that, I'm just going to do a quick guide here. This rectangle here is 3 boxes long, 2 boxes high. Now you can do it with center. If you don't have squared paper, you can do it on plain paper with using centimeters, or you can print off a sheet from the internet of a grid. So what we would do, the scale factor in the first case is 2. All that means is that we're going to multiply, in each case, the dimensions of the shape by 2. Okay, 3 times 2 is 6, 2 times 2 is 4. So in the first instance, to do that other shape, what you would do is that you would draw a shape that's 6 boxes along, 4 boxes down. You'd complete the shape, and then to emphasize the fact that where the shapes come from, we can say you can either write inside it or write underneath. We can write the scale factor equals 2, and that maybe helps also if you can write the numbers along the side, especially if you've got plain paper. Okay, so if it's the scale factor is 3, you're going to multiply the sides by 3. 3 2s are 9, 3 2s are 6, so you have a 9 by 6 one, and then multiplying by 1.5. 2 times 1.5 is 3, 3 times 1.5 is 4.5. Sometimes you might want to do a wee calculation. Well, remember, so the scale factor would just be 1.5 multiplied by 3. 3 times 5 is 15, 3 times 1 is 3, plus 1 is 4. So that would be 4.5 boxes along. Okay. When it comes to the triangle, it's 2 boxes high, so again, you're going to have to multiply both the dimensions by the scale factor. Right? So I'm going to get you to pause it, have a go at doing these shapes, and on the next screen I'm going to show you what your answer should look like. Okay, so pause it just now and have a go at drawing these enlargements. Okay, so hopefully you've had a go at that. So this is what your shape should look like. So we've got our 3 enlarged rectangles, and then we've got our 3 enlarged triangles. You notice that we're always talking here about the straight up down vertical height, so that would be 4, and that's going to be 6, and then we've got 3 boxes high there. Okay, and lastly, I'll just if I can bring this up. Here is the block shape ones as well. It's not so difficult when it's when the lines are along boxes, all vertical or horizontal. What happens when there's sloping lines? Okay, so the next challenge is to have a look at this one here. So we're going to draw similar shapes, and this time you're going to draw 2 enlargements, and we know that because 2 of the scale factors are bigger than 1. So 3 is greater than 1, and 1.5 is greater than 1, so they're going to be enlargements. But you notice here, the one at the half, that's smaller than 1, so you're going to make a reduction. Now when you've got sloping lines that go through boxes, I would suggest that you just kind of ignore that as much as you can first of all. Sometimes you can just get away with looking at the horizontal and vertical lines. So in this case you could, let's take the 1.5 one. First of all, so we would do 2 times 1.5 is 3, so my height would be 3, and then 1, 2, 3, 4 times 1.5 is 6, so my base is 6, and you notice that all I need to do is to draw a line between those 2 points. I don't need to consider the size of that. If I did though, it's not such a bad thing, because let's have a look at this sloping line. Do you notice that to get from the top to the bottom here, if I did this from top to the bottom, I would go 4 boxes right, and I'd go 2 boxes down, 4 boxes right and 2 boxes down. Well, all I would need to do is to apply the same scale factor. So 1.5 times 4 boxes along is 6 boxes along, and then 2 boxes down times 1.5 is 3. So you can still use the number of boxes along and up or down, like the gradient, to draw a sloping line. But sometimes you can get away by just working out other ones and then filling in the extra line. Again, I would finish this off by writing in what the scale factor was. It's just, again, good communication. Scale factor equals 1.5. So have a go at, I've just done one of them for you. Let's rub this out. How you have a go at just drawing these 3 shapes. Pause it and I'll show you what the answer is. Okay, so there's your 3 shapes here. Scale factor of 3, scale factor of 1.5, and scale factor of 0.5. Okay, one more set of drawings for you to do. So these are all fractions, but you notice that 2 of the fractions are less than 1, that's A and B, and 1 of the fractions is still greater than 1. So that's going to be an enlargement. So you can see how many of these you can do. Remember that it's about multiplying by fractions. I'll remind you, for instance, that what we can do with fractions is divide, the best way to work this out. If I have the dimensions of a shape, so say I've got a 6 here as the breadth of my rectangle. If my scale factor is 3/4, then all I need to think about is 3/4 multiplied by 6. So a couple of ways of doing that. You can think about dividing by 4 and then multiplying by 3, or you can think about the idea of 6 as being 6/1, and then we can just multiply 3 times 6 is 18, 4 times 1 is 4, and simplify the fraction that we've got. That would give us 9/2, or 4.5. So in this case here, you might be able to work that out as 4.5. There's other ways to work out 3/4 of 6, of course. So there's different ways. You can do it mentally, you can do it written. It's really important that you already have an idea in your head as to what's going to be an enlargement, what's going to be a reduction based on just the fact that the scale factor is greater or less than 1. So again, pause the video and I'm going to show you what your answer should look like in drawing these reduction and enlargement shapes. Okay, so pause the video just now and have a go at these. Okay, so we'll try and cram it all in here. The yellow shapes should look something like that, if you can check that yours are the same as mine. And then the rectangle, the 6x10 rectangle, then turns into these other ones here. And then this other trapezium shape, I'll just bring it up. That's what we should have here. Again, this is a shape that would probably be easiest to draw, just working out the 3 horizontal and vertical lines and then just filling in the gap. But you can work out the gradient of that sloping line as well. So hopefully you get the idea that scale factor helps us to make a shape look bigger or smaller, and it keeps the same proportion. So just to summarize, what we're saying here is that congruent shapes are identical. Similar shapes are not always identical in size, but they have that same proportion, and one is always an enlargement of the other, and they have a common scale factor in all of their sides. And that multiplier, the scale factor, if it's greater than 1, it will enlarge. If it's less than 1, it will reduce. And the key thing that we can use, this is what we're going to do in the next lesson. See if you can actually work this out. We've got 2 similar shapes here. One is 6 centimeters long, 4 centimeters high. The other is 12 centimeters long, and we're not sure of the height. Can you work out just from that diagram what the height of that rectangle is? Well, hopefully you can, because you might have noticed from the information given that if it's 6 centimeters long here and 12 centimeters long here, that there's actually been a multiplier of 2 in the length of the rectangle. The length here is double the previous one. And if the shapes are similar, only if the shapes are similar, it means that every side has been doubled, which means that 4 times 2 is 8. We can confidently say that if these shapes are similar, then the height of the rectangle has to be 8 centimeters. So we can go on and solve problems in terms of working out dimensions and area and volume using the scale factor. So it's quite an interesting topic, and that's what we're going to do from the next lesson onwards. Okay, hope that's been helpful and that you've got a good idea about scale factor.